In this lesson, we're going to learn to draw Lewis diagrams for covalent molecules. Now, you've already had some information given to you about how to draw the valence electrons around a single element, and we've looked at ionic compounds. So this is going to be the Lewis diagrams for covalent molecules. The rules here should help you be able to draw the diagram for any compound that you're given if you follow the rules. The first thing you need to figure out is how many electrons are going to be in the drawing. Once you figure that out, look at your formula and determine what the central element should be. Now, the central atom should never be hydrogen. A lot of times it's listed first in the formula, but that's not a guarantee. You want to find the element that needs the most electrons to get its octet, or the 8 valence electrons. Then, once you choose the central atom, connect the other elements around it, bond them all with one single covalent bond with 2 electrons, and then you want to add electrons to every atom in the diagram to give them the octet. Now, the only exception to this is hydrogen. Remember that hydrogen only needs 2 valence electrons to satisfy it, but every other element in the periodic table wants 8. And then finally, do your count and check. Does the number of electrons you have in your drawing equal the number of electrons that you calculated? If it does, then you're done, and you probably have a good Lewis diagram. Now, if you don't, here's what has to happen. If you do not have the same number of valence electrons in your diagram as you calculated, you're going to have to draw a double bond or maybe even a triple bond. So you're going to do erase, draw, erase, as I like to call it. You're going to have to erase an unshared pair on one of the elements that you want the double bond between, then draw the double bond in and erase an unshared pair from the other element that's going to be involved in the double bond. Don't ever put a double bond on hydrogen or on any of the halogens because they're not able to make double bonds. Hopefully these rules will help you. Once you do that, then do your count and check again. If your answer still does not match what you have in the drawing, do another double bond or make a triple bond. Now, I know those rules are a little confusing. We're going to do some examples in this lesson, so I'll show you how to use the rules and you'll understand better what these mean. But before we do that, I want to talk to you about the symbols and just a few of the definitions that you've seen here. Each one of the dots that you draw on your paper is going to represent 1 electron. So, for example, when we say that hydrogen has 1 valence electron, you would draw the symbol H with 1 dot or 1 electron beside it. Now, when you start bonding atoms together, they have to bond with a pair of electrons, which is 2. But a lot of times people don't draw 2 dots, they'll draw a stick or a dash. 1 stick represents 2 electrons. So there are 3 types of bonds: single, double, and triple bonds. A single bond is when 2 atoms share 1 pair of electrons, so it's represented with 1 stick. A double bond is when 2 atoms share 2 pair of electrons, so it's represented with 2 sticks. And a triple bond is when atoms share 3 pair of electrons, or 6 electrons total. We would represent that with 3 sticks. When you look at a Lewis diagram, there are shared pairs, which are the electrons that form the bonds. They're drawn between atoms. And there are unshared or lone pairs. Lone pairs are the ones that are around the edges of the diagram. They're not forming bonds. They're only there to help an element give its octet. Alright, so let's try some examples. In this first problem, we want to draw the Lewis diagram for CH2F2. Now, CH2F2 is a covalent molecule. I want to follow the steps. The first thing I have to do is calculate how many valence electrons each one of these elements has. So I'm going to go to my periodic table and I'm going to look. Carbon is in group 14, so it has 4 valence electrons. Hydrogen's in group 1, and there are 2 of them, so that's a total of 2. And then fluorine, I have 2 of those, and each fluorine has 7 because they're in group 17. So that's 14, and this is 2, plus the 4. I'm going to add all that together. That gives me a total of 20 electrons. That's my goal for this Lewis diagram. the next step is to choose the central atom. Well, I know it could never be hydrogen. I know a lot of times it's written at the beginning of the formula, so carbon is a good choice, and I'll give you a hint. Carbon is an excellent central atom. Plus, carbon has 4 valence electrons. It needs to share 4 to get a total of 8. Fluorine already has 7. It only needs to share 1 more. So I think carbon is the best central atom. So I'm going to draw that, and then I'm going to connect all the other elements around the center of my molecule. It doesn't really matter where you draw the hydrogens and the fluorines, just draw one on each side of the carbon. And now I'm going to connect them together. Remember that I can use sticks here for my shared pairs. So that represents 2, 4, 6, 8 of those electrons. I've drawn 4 single bonds. Now I need to give every element its octet. Fluorine so far only has that bond with it. So I'm going to add 6 more electrons to give me 8. And I'm going to do the same thing with this fluorine. Hydrogen, remember, doesn't need 8 for a full outer shell. It only needs 2. And this single bond is 2 electrons. So that hydrogen is good. The hydrogen on the left is the exact same way. There's 2 electrons in that single bond, so that hydrogen is satisfied. Don't forget to check the octet around your central atom. Carbon needs 8, and there are 4 single bonds around carbon, which is 8 electrons. So I think this seems good. Now the last thing I need to do is count and check. I need 20 electrons, remember, in this diagram. So I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So with the single bonds, I do have 20 electrons. So I think this is a really good valence electron diagram, or Lewis diagram, for CH2F2. Let's try another one. NH2Cl. Right, let's get the total number of electrons first. Nitrogen is in group 15, so it has 5 valence electrons. My hydrogen is in group 1, and there are 2 hydrogens, so that gives me a total of 2. And chlorine is in group 17, so it's going to have 7 valence electrons. Now when we add all that together, I get a total of 14 valence electrons that should be in this diagram. That's my goal. Which element should be in the center? Well, I know it's not hydrogen. Chlorine has 7 valence electrons, so it only needs to share 1 more to get 8. Nitrogen has 5. It needs to share 3 more. So I think nitrogen is the best choice for a central atom. I'm going to draw the nitrogen in the center, and I'm going to put the 2 hydrogens and the chlorine on 3 of the sides. Again, it does not matter where you put the hydrogens and the chlorines, as long as you draw 1 on each side. Now I'm going to connect them with single bonds. Remember that that represents 2 electrons, that represents 2 electrons, and that represents 2 electrons. So I've got 6 in the diagram so far. Now let's go through and give every element the octet. These hydrogens are good because hydrogen only needs 2 electrons to fulfill its octet. Let's do the chlorine. It has 2 so far, so here's 3, 4, 5, 6, 7, 8 total. And don't forget your central atom. Nitrogen right now has 3 bonds around it, so that's a total of 6 electrons. I need to give it 2 more here for its octet. Now when you do all of that, it's time to count and check. 2, 4, 6, 8, 10, 12, 14 electrons. So we matched up. We predicted we would have 14 electrons, and our diagram actually does. So I think this is a good Lewis diagram for NH2Cl. Now those diagrams all had single bonds. Let's take a look at some more examples. These are going to be ones that don't only have single bonds. We're going to have some double and triple bonds in these. Alright, so the first thing that I need to do is count up my electrons. Carbon, remembers, in group 14, so it has 4. I have 2 hydrogens, and each hydrogen has 1 valence electron. And then oxygen is in group 16, so it has 6 valence electrons. So my total here is going to be 12 valence electrons. That's my goal for this Lewis diagram. I'm going to put carbon in the center because remember carbon is an excellent central atom. I'm going to connect the hydrogens on two sides. I'll put oxygen on a third side. Let's give every element its octet. The hydrogens have their octet. Oxygen needs to have 6 more for a total of 8. And then don't forget carbon in the middle. Just add its 2 more electrons. So now carbon has 3 bonds plus an unshared pair. That's a total of 8 electrons around it. We should be done. Let's count. 2, 4, 6, 8, 10, 12. This drawing has 14 electrons. That's too many. We need 12 as our total. So I can't leave this that way. What I'm going to have to do is to make a double bond. Now you can't make double bonds on the hydrogen, so my double bond's going to have to go right here between the carbon and the oxygen. What I'm going to do is show you this process. I'm just going to change the color of the pen so you can see the new drawing. I'm going to erase that lone pair off of the carbon, and I'm going to redraw it as a double bond here. And then I'm going to erase one of the oxygen lone pairs. It doesn't matter which one you choose to erase, just pick one of those 3. Now let me redraw what I have. I've got hydrogen, a double bond now between carbon and oxygen, and there's only 2 pair of unshared electrons on oxygen. Now let's count and check how many we have. I've got 1, 2, 3, 4, 6, 8, 10, 12. Now we have a total of 12 electrons. By using the erase, draw, erase method, I was able to put a double bond between carbon and oxygen, so they still have their octet and they're still satisfied, and that gives us a good Lewis diagram. There are 2 single bonds in this one and 1 double bond, and then 2 unshared pairs on the oxygen. Let's try one more. This last one is the Lewis diagram for HCN. Let's get our total first. Hydrogen is in group 1, so it has 1 valence electron. Carbon's in group 14, so it has 4. And nitrogen's in group 15, so it has 5. That gives me a total of 10 valence electrons to go in this diagram. Now, hydrogen can't be the central atom, so between carbon and nitrogen, carbon needs to share more than nitrogen does, and remember, carbon's an excellent central atom anyway. So I'm going to put carbon in the middle. I'm going to draw nitrogen on one side and hydrogen on the other. And it doesn't really matter if you draw it on top and bottom or left and right. Just connect them in this order. Now I'm going to put a single bond between carbon and hydrogen and a single bond between carbon and nitrogen. Now let's give everything else the octet. I've drawn the extra electrons now around the nitrogen, so it has a total of 8. I'm going to do the same thing for carbon. It has 2 bonds, and now it has 2 unshared pairs. Hydrogen doesn't need an octet. It only wants that 1 single bond. So we're to the point where we should count and check. I've got a total of 2, 4, 6, 8, 10, 12, 14 valence electrons. You can see that that's too many. My prediction was 10, so 14 is not going to work. I'm going to have to do the erase, draw, erase technique again. So I'm going to change to the blue ink again so you can see the difference. I'm going to put the bond between the carbon and the nitrogen because hydrogen can't form more than 1 bond. So I'm going to erase a pair off of carbon, and I'm going to redraw it there, and I'm going to erase one of the pairs off of the nitrogen. That's erase, draw, erase. Now let's recheck. I've got 2, 4, 6, 8, 10. Now I've got 12 valence electrons. That's better, but it's still not the predicted 10. So I'm going to have to do erase, draw, erase again. This time I'm going to use green ink so you can see the next set of erasing. I'm going to erase another lone pair off of carbon, redraw it as a triple bond, and I'm going to erase another unshared pair off of nitrogen. Now when you count and check, you have 10 valence electrons. we finally made it to our prediction. So I'm going to clean this drawing up for you and show you what the final answer should look like. We have a single bond connecting the hydrogen and the carbon. We have a triple bond, which is represented with 3 sticks between the carbon and the nitrogen, and I'm left with 1 unshared pair on that nitrogen. So that gives me a total of 10 valence electrons, which is what we predicted. That's a good Lewis diagram for this molecule. So if you will follow those rules, you should be able to draw the Lewis diagram for any molecule that I give you. Thanks.